I'd like to welcome everyone to the Best Practices for Building Security into Your APIs webinar, hosted by Near BPO and partnered with APIsec. APIs are the front door to applications, and as a result, they expose the business logic and access controls that exist within the application. Developers now need to fully understand that exposed business logic and vulnerabilities within it to then securely grant access to the API. Given the rapid pace of development with APIs, it is critical to ensure security is integrated into the CI/CD process. This webinar will share real-world best practices for embedding security into the development cycle to prevent API vulnerabilities from making it into production. I'd like to welcome your speakers today. I'd like to first welcome Bernardo Perez de Lara. He's the CEO of Near BPO. Welcome.
Hi.
I'd also like to welcome Dan Barahona. He's the CMO and VP of Business Development at APIsec. Welcome, Dan.
Thank you.
I'd like to now turn it over to Bernardo, who will take you to the first part of the webinar.
Thank you very much, Sumita. And also I want to thank Monica from our team who helped Sumita make this happen. I'm very, very pleased to have you all attending this webinar. Well, most of you know me. Most of you know what Near BPO is because some of you are our partners and we have worked with you. And it's a great opportunity to introduce you to the parts of security that we think are very important for the corporations. So about Near BPO, well, we have been doing things related to API since 2012. So we have several engagements, experience, and projects that have gone through in the whole continent. So most of our customers are in the US, Mexico, and Brazil. And we have had the opportunity to work with leading enterprises in Latin America in the different sectors. Mostly our customers have been in the financial, telecom, and retail sectors. And some of you, of the people who are attending this presentation, come from those segments. I'm very proud, and it was an honor to receive the Google Cloud Web Partner of the Year in 2020. And Near BPO we all lived a very, very different and very difficult year in 2020 in some ways. And to have in this disruptive year the opportunity to be one, recognized by Google, and two, have been able to work with our partners, with our customers, to make them address the requirements of this new reality has been a challenge and a very successful option that we have had. So we are very happy and very relieved that we were able to provide services to enable our customers to continue progressing and making good steps in the digital transformation and the business evolution. When we talk about business evolution, because we see APIs not just as a project, but as a product, something that has life, that you can take with you and make it something that is continuously doing new things and enhancing your capabilities, because you want to create an ecosystem. And that alignment of the vision of the business side with the execution on the technology side is really important, and we focus on that. An ecosystem enables the companies to have a better customer relationship. It has been clearly shown that the companies that are part of ecosystems are perceived to be better in the customer relationship. Adaptability is important too. We need to, more than ever, realize in 2020 that adaptability, to be able to do something new in the presence of something unexpected, is really important. And of course, security. And that's why we have this conversation today with you. With our customers, we have worked mainly in the enablement, making sure that they understand how to interact with the API technologies. And we also have a continuity process where we work with them. We don't just disappear. We come back and we work with you to make sure that you continue to do the nice things that you should be doing. And one of the important things to be done right now is focus on security, because security is not just compliance. Security is not just to making sure that you are doing what the regulators asking you to do. You want to make sure that you're doing things that are protecting the information of your corporation, because APIs are not just external, they are also internal, and you want to make sure that only the people that need to know have the knowledge of the information. Externally and in general, APIs have to be very secure. And the most common problem right now is API abuse, by becoming all these teams that are trying to attack your systems, because APIs are meant to person, not person to person, sorry, computer to computer communications, which enables the the attacks from systems that are there ready for you to take advantage of what you're doing. So we look for a partner that will help us have a good view on what security is, how to protect our customers. And that's why I want to introduce you to Dan Barahona. He is from APIsec, and he will give you a good interesting introduction into why we think security is very important. Dan.
Wonderful. Thank you so much, Bernardo. That was appreciate the warm introduction. And let me just make sure I'm sharing the correct. Okay. All right. Can you all see my presentation? It's not showing. Hold on. Here we go. All right. Sorry for that little delay. So thank you again, Bernardo. It's really a pleasure to be here and to be able to talk about building API security into your dev process, and how to build security into building your APIs. What I want to do today is talk a little bit about API security in general, some of the challenges, some real world examples of API breaches, why hackers are targeting APIs as such a profitable and productive target for their attacks. Kind of review the different approaches, the landscape of approaches to API security, and some best practices. So with that, let's dive right into it. This slide is probably very well known to everyone on the call. APIs are everywhere. They have really transformed how organizations build, run, scale, manage, develop their apps. And we see now fully 83% of internet traffic is API based, according to Akamai. And this, amazing productive value of APIs and the amazing adoption, of course, has led to a downside, and attackers have, really seen a very fruitful target with APIs, and have really made it a primary target of choice for breaches. Gartner even predicting by next year, APIs will become the most frequent attack vector for breaches. And there are a lot of good reasons why this is such a preferred target for attacks. And so let's dive right into that a little bit. If we think about kind of our classic, stack here, you've got, web applications and mobile applications that are now communicating with the back end via APIs, right? These APIs power the functionality of our UIs, our mobile apps and web apps. And those APIs have now grown to, and the security that we've typically imposed on these web and mobile apps, things like mobile and web app scanning, web app firewalling, code scanning, SAST and DAST. These are very well known, tried and true technologies for securing our UIs, the mobile and web apps. And they are all now relying on APIs to communicate with the back end. Those APIs are now wearing multiple hats. Many organizations, sorry.
Yeah, and I apologize to interrupt. I believe that some of the people cannot see your screen for some reason. So why don't we do this? We'll just quickly, if you can remove yourself as a presenter, and I'll re-add you again, and maybe you could reshare the slides.
Remove myself as a presenter.
Thank you for your patience, everyone. We'll fix that right away for you. Give us 1 second. 1 second here. All right, and we make you as a presenter. Okay. Dan, if you can try and share your slides now, you should be able to share.
All right, let's see if this works any better. It's just not showing anything. All right, are you seeing my PowerPoint now?
Yes, I can see some people saying they can see it now.
All right, thank you for the heads up. Well, fortunately, you didn't miss the exciting parts of the presentation, but I'll just backtrack a little bit here. So I was showing here this sort of classic stack of mobile and web app UIs communicating via an API to the back end. That we have security technologies to scan and protect and firewall these web apps to code scan as well. But these APIs are not just powering our web and mobile interfaces. They are now being exposed as often as public APIs, externally visible APIs, APIs that customers and partners can use and integrate with. Those APIs are also helping us transform our legacy applications into microservices, containers, and things like that. So these APIs are really very powerful. They can enable tremendous capabilities and functionality, but are also becoming this really ripe target for attacks, right? For various reasons. These APIs offer direct access to the most sensitive back-end data. So if you're able to breach at the API layer, you've bypassed a lot of the security controls and now have direct access to that information. We had a very fascinating conversation with a CISO of a large energy company who confirmed that they are widely adopting APIs, and the security person said, whenever we look under the hood of those APIs, we discover they are often over permissioned. This is not uncommon, right? In the rush to push code and functionality out, these APIs often get pushed out with excess permissions or with loopholes or logic flaws that can lead to significant breach. And these are the types of things that hackers are specifically looking for. If they can find those APIs where there is an unintended use case or capability that's permitted, that can be what leads to harvesting data, unauthorized access, and the like. And to hammer that point home, I want to walk through a few examples. So I'm sure a lot of you on the call are familiar with the OWASP top 10. There's now the OWASP API top 10 specifically for APIs. And I want to focus on the top 5 of that top 10. These are the most serious threats and risks for APIs, and walk you through some real world examples. Each of these examples relate to a company that surely has prioritized security and yet still suffered these types of breaches. So the first one, OWASP number 1, broken object level authorization. This is effectively are there any controls to prevent user A from accessing user B? The example here is Postal Service. They had an API called Informed Delivery. Basically allowed a shipper to access shipment information, where our package is, what's the estimated delivery date, who signed for it, customer details, and so forth. Turned out that API did not have a control to prevent the query string from being manipulated, increment an ID by 1, for example, and suddenly instead of looking at your own data, you're looking at somebody else's data. And somebody discovered that they could do this, and then of course iterated through 60 million accounts and harvested all of that information. This is a classic API flaw where there are loopholes that allow this type of access to other users' information to happen. OAuth number 2, this is about broken authentication. So, weak password policies or reset mechanisms and the like. Example here is Physical, which is a fitness application. Simple example, if you forgot your password, they'd send you a 4-digit code to your email or to your phone. That's only 10,000 different combinations. Very easy to iterate through with an API and very easy to take over anyone's account. OAuth number 3, excessive data exposure. So in many cases, the API is designed to retrieve, an entire record of information, and we rely on the UI to filter out what's needed for the user and what's not. In the case of Venmo, they had an API that powered a feature on the homepage that would show the most recent 20 transactions. And the homepage would filter out the sensitive bits, but the API would return all of the information. It turned out that API could be called directly, and a hacker discovered they could do this. They could run that up to 100,000 times a day and return all of the fields, all of the details, the transaction information, the to and from, account details, and so forth. So the API was returning far more information than was needed for that application, and the hackers were able to access quite a lot of sensitive data. Number 4, lack of resources and rate limiting, so kind of classic denial of service. This one is Instagram. Again, an example of an account takeover, but here Instagram, if you forgot your account password, they'd send you a 6-digit code, so a million different combinations. And they also enforced a 10-minute timeout and no more than 200 guesses per IP. The problem was they didn't restrict the number of IPs. So some enterprising hacker created a server farm and just iterated from IP to IP to IP until they got to the right code. And they could take over literally anybody's Instagram account by doing so. And the last example here is broken function level assignment. Example is Bumble, where they had an API that was pretty open and allowed a user to access almost all of the data. But beyond that, they could actually modify and change the settings on the back end. So this particular user not only could view millions of users' accounts, but they could actually activate premium features and the like. It's sort of like being able to view your invoice, but also be able to delete it, right? In this case, the user not only had get method, but they also had put and post. And so that was an example of broken function level assignment. Now, none of these companies, take security lightly. I think this is a great example or set of examples for how difficult it is to prevent these types of loopholes. And the common thread amongst all of these is that these are not your classic security type of vulnerabilities. Not one of these is a cross-site scripting or a SQL injection, buffer overflow, or any of those types of things, right? These are breaches where the attacker discovered a flaw in the logic of the API and was able to take advantage of that to harvest information. So how do we go about securing APIs and what are the options there? So they're really, just like with our web and mobile apps, right? You can do things at design time, at test, or in production, in runtime. And so I want to kind of review these across two different categories, security vulnerabilities and logic flaws, and what are the options available to us. So at design time, it's kind of classic, SaaS, static analysis and the like. It's very, sort of, time-tested capability. It's great for looking for code flaws and vulnerabilities. When it comes to, to finding, the more serious types of logic flaws, very, very difficult to use technology like this. And because it's at design time, it's not a full operating application. You get quite a lot of false positives. At test time, here we're talking about dynamic application testing, great for finding, SQL injection vulnerabilities, cross-site, denial of service, and the like. At runtime, we're looking at things like gateways, API gateways, and firewalls. Very effective technology, great for API discovery, discovering unknown APIs perhaps. Relies on anomaly-based detection, so looking at what's normal traffic and then trying to discern what's abnormal. Great for looking for bot traffic or denial of service, but can introduce latency and other types of issues. Now, these are all sort of tried and true technologies, well known to most of you on the call, I'm sure. But when we look at those business logic flaws, right, the types of things that we were just reviewing on the prior slide, things get a lot trickier. These are the most dangerous types of vulnerabilities and the most difficult to discover. Frankly, at design time and in runtime, very, very difficult to detect these things. A firewall, if we take that postal service example of user A accessing user B, these tools don't have the context to understand, am I accessing my data or am I accessing your data? And really, the best place to find these types of logic flaws is with testing. And the state of the art has been primarily manual, right? Pen testing, red teams, using tools like Burp and Zap to automate and run your tests. But of course, it's manual, and so there are speed, concerns. It takes, days, weeks to run these tests. There's coverage limitations. These APIs can have, hundreds of endpoints multiplied by, 3-4 different methods times multiple attack vectors, and you're looking at literally thousands of unique tests required to really properly exercise every corner of an API. And so and then of course the goal, of course, for many CISOs and most organizations really is that they don't want to find these vulnerabilities in runtime. They don't want to see these vulnerabilities pushed all the way into production and have it discovered there. That's far too reactive and frankly dangerous. The goal is, of course, to find these in a pre-production environment, and that's what we're really here talking about. And so I love this quote. I think Corey might be on the call here today, but he says it better than anyone, right? If you design the most secure API but don't test it, don't worry, some cyber criminal is going to do it for you. Highly recommend you go look up Corey and his upcoming book on hacking APIs. But it really does hammer the point home, right? To find these most dangerous vulnerabilities, you have to test. And you have to test at scale, and you have to test continuously at the speed of DevOps. So I'm going to pivot a little bit here. I'll show you a little bit about an automated API testing approach here at APIsec. If the demo gods will play nice, I'll show you a live demo as well. But basically, the how it works is we do really these 4 things. You register your API with APIsec. It's a cloud-based service. So registering it simply means, point us at your gateway or hand over a definition file, whether that's OpenAPI, Swagger, Postman, RAML. But at the end of the day, what matters to us is simply a glossary of the API endpoints and the methods they support. It does not need to be any more detailed than that. With that, APIsec will auto-analyze the entire API and really build a roadmap of functionality and capabilities of your API. The second step is we then auto-create thousands of tech playbooks mapped to the OWASP top 10, exercising every single one of the endpoints and every method. And then we run those attacks. The goal is to pressure test the API in every possible way to find ways to get it to leak data, to provide unauthorized access and functionality. And by doing that, that's how we discover vulnerabilities, right? And we can score those on CVSS, a severity rating, and integrate that right into your CI/CD pipeline. You can orchestrate this all with Jenkins so that, with every nightly build or as soon as, API is pushed into staging, you're automatically kicking off these APIsec scans. And as we discover vulnerabilities, we are auto creating tickets to push into Jira, GitHub, ServiceNow, and the like, and to really push this API vulnerability and logic flaw detection into the dev cycle so that they don't ever make it into production. Now, from a deployment perspective, we call it zero touch, which means it doesn't require any source code access. We don't need you to install any agents or instrument your containers or APIs with any special code. And you don't need to change anything on your network. There's nothing in line. We're not introducing latency. The way APIsec works is we kind of act like a hacker would. We're going to use credentials. We're going to run tests that require no credentials, or we're going to ask you for a set of user A, user B, user C type of credentials that can be used to exercise the API in that pre-production environment. And so let me show you a little bit of how that actually looks in real life. So let me switch windows here. So Sumita, you'll keep me honest in case no one can see this, but this is what the APIsec interface looks like. And as I mentioned, first step is to register your API or to integrate us with the gateway. Very simple process, takes a few minutes to set up. Here I've already loaded a demo app called Net Banking. And like I said, step one is you register your API and then we dissect it. And you can see all of the endpoints, the methods, and so forth that we have broken this API into. We then combine that with our knowledge of over 100 different categories of API breaches, whether it's attribute-based access control, excess data exposure, unsecured endpoints, incremental IDs, rate limiting, role-based, SQL injection, you name it. These are these 100+ categories. So we combine those categories with our knowledge of your API to auto-fabricate, auto-create, in this case, over 1,200 unique custom-made attacks for your API. And you can come in and actually view every one of those attacks. You can modify if you choose, but every one of these attacks includes a set of assertions. These are what we're expecting the response to be from the API, and if we see anything that deviates, that suggests to us we've tripped across a vulnerability. So you can then, of course, run the scan. One thing to mention is if your API is internal and not internet facing, that's not a problem either. You can simply drop a local scanner. It's a simple Docker container, and you've got your own local scanner that will phone home to the cloud. So in this case, we've run the scan, some 287 vulnerabilities discovered, which are all available down here. And so I want to show you one in particular. You see that all the vulnerabilities are mapped to the OAuth category. We know which endpoint they apply to, what category failed, a CVSS and severity score. And as I click in here, I get more detailed information about that vulnerability, including the wire logs, which is really the recording of your vulnerability. In this case, this is a bank transfer. We logged in as user A, and we're simply creating our own bank transfer. That's pretty normal. And as expected, we get a confirmation code back from the server. Now it gets more interesting. What we're going to do next is we're going to come back to that endpoint, and we're going to append that confirmation code, but this time as user B. And we're going to try to delete it. So this is a classic BOLA, broken object level authorization type of attack. It's OAuth number 1. It's exactly the postal service example, if you will. What we're going to expect, of course, is that this is denied, right? We get some sort of response error or 401 or 403 because user B should have no access to user A's information. But in fact, what we get back is no errors and a 200. Okay, so it suggests that user B in this case was able to successfully access user A's transaction and delete it. And we actually come back for a third step, which is to log in again as user A and try to delete our own transaction. And in fact, it says that transaction no longer exists. right? So this gives you a feel for the ways that APIsec actually can pressure test the logic of an API. Surely we can do SQL injection and these types of things, but the really dangerous type of vulnerabilities are those logic flaws. And this is a good example of how we can find them. We do provide remediation guidance as well. And as I mentioned, you can integrate this into your ticketing system, into your orchestration system, and so forth. So that's a very quick tour around APIsec, and I will finish up with just one more slide and a special offer. So, I thought I'd share one quick case study of how customers are actually using this type of capability and how they are truly building API security into the dev pipeline. The customer here is Seismic. You may know them. They're very large cloud-based sales and marketing automation and enablement tool. Their customers are trusting Seismic with very, very sensitive confidential data. They need to make sure that that data is not accessible to anyone else. From a challenges perspective, of course, they have widely adopted APIs to build out their service, and they expose those APIs to customers, all right, to provide more integration capabilities to enable their own workflows. And customers started asking, how are you protecting our data? So what they did was they deployed APIsec into their staging environment. So whenever new code pushes into staging, they're automatically pushing that code into those APIs into APIsec. We build and execute those new playbooks, find vulnerabilities, and then integrate the results back into the development tool chain. They were actually able to eliminate a lot of their manual pen testing efforts, paid for the product in just 3 months. And Tim, their VP of Information Security, says this is what we show our customers when they ask us how are we protecting their data with APIs. They show what they're doing with APIsec, and it really provides that confidence that they can trust the service. So with that, I really appreciate you all being part of this conversation and listening to the talk. We do get a lot of questions from folks that say, does that testing capability really work? Will it work on my own API? And so what we'd like to offer to everyone here on the call, simply go to that URL down in the red box there, and we'll be happy to schedule a live test against one of your own APIs, your API of choice. We'll send you a document on how to get started. It's a very simple process. We'll give you a full pen test report with all of the findings, and would love to show you how this technology can work for you. So with that, I thank you, and Sumita, let's see if we have any questions.
Perfect, thank you. If I can ask Dan and Bernardo, perfect. We actually have lots of questions from the audience. I'm going to begin with the first one from Megali Agarwal. Should company internal APIs also implement the API OWASP top 5 security vulnerabilities? And I will throw that out to Dan if you wanted to maybe take that first, and then Bernardo if you wanted to add to that.
Yeah, I mean, I think the OWASP organization has really, it has long been a Bible of app security, and they, very presciently noted that APIs are unique and different, and didn't simply extend the existing, web app top 10. They actually created a brand new top 10 specifically for APIs. And that top 10 for APIs is actually almost completely unique and different from the classic web app. So I would absolutely recommend that you look seriously at the OWASP API top 10. It is a remarkable sort of guidance on the types of threats that are really dangerous for APIs. We provided some review of them here. So I definitely recommend that you get familiar with the OWASP top 10 and look at how you can mitigate those types of risks.
And I think as part of the question was if it was internal, and as I said during the introduction, there is in all companies there is a policy of needs to know basis. So you don't want, even for internal people, don't have the right security in your API.
Perfect, thank you. Our next question is from Ronald Mueller. Is this service a SaaS offering? How will it be integrated into a CI/CD pipeline? And I will throw this out to both of you.
Yeah, I'll jump in real quick. It is SaaS based, so APIsec is hosted in the cloud. If your APIs are external facing, then we do have a scanner component, and if it's external facing, then you can simply use our cloud hosted scanners, or if you prefer, you can deploy your own scanners, and if your API is not external facing, you can deploy those scanners locally on premise. It's a one-way communication out to the cloud, so there's no ability for the cloud to reach in to your private scanners. And we make sure, of course, that all data is encrypted in REST, that in transit, that there's data segmentation and the like. But it is a cloud-based solution, and there's really very little to manage and to deploy.
Perfect. Our next question is, how do you handle APIs that don't follow the REST standard errors? For example, API returns 200 with an error message instead of 401. API validates authorization but returns empty 200 instead of 401. I think maybe, Dan, you want to take this
Yeah,
one?
that's a very detailed question, and probably if you got further interest, we'd be happy to spend time one-on-one with you. But yes, this is part of kind of the tuning, if you will. Just yesterday we were on a call with another client, and they use 406s instead of 403s, and so these are all sort of configurations that you can specify on a per test basis, on a per category basis, or globally within APIsec. So we understand that every organization doesn't report errors in exactly the same way. So we have a very flexible way to define those assertions and what is a fail, what is a denial, what is an error, and to make sure that the tests are savvy to understand what your specific error codes look like.
Perfect. Our next question is, does APIsec only detect API vulnerabilities, or does it also provide solutions guidelines for security IT?
Yeah, so I'll jump on that one, Bernardo, but I will ask you to jump in on I believe that Apigee actually offers quite a lot here. So, so we focused a lot of my talk on the logic flaws. It's not to say that we don't also look at kind of classic security things. So you might have noticed categories for SQL injection, denial of service, rate limiting, these kinds of things. But I know, Bernardo, you and your organization have a lot of expertise with API gateways, which are now offering quite a lot of functionality as well.
Yes, and with Apigee in special, there are some things that use artificial intelligence to test your APIs to make sure that the bots are how you are being attacked. And so yes, the gateway, the Apigee itself has a lot of security features to make sure that you can protect yourself. But it does not cover all the breadth of the things that you can do with APIsec on the side of logic and things like that.
Perfect, thank you. The next question is, how much of this process is automated and how much is manual?
Yeah, it's a great question. So it's highly automated. You can give us a Swagger file and a set of credentials, and we'll go off and running. Where the manual part comes in is in things like if you have unique error codes or the authentication mechanisms, if it's token based or things like that. There is some setup involved to get it fully up and running, but really the hard heavy lifting is as automated as can be. Specifically, the creation of those thousands of tests, and this is really where a lot of the sort of magic of APIsec exists, where we can auto analyze your API and really understand what the functions are, the endpoints, the variables, the methods available, and then to combine that with all of those 100+ different categories of attack types for APIs, and to mesh those together and auto create all those thousands of tests, make sure there are tests to exercise every endpoint and every method against all those OWASP categories. That's really where the automation comes in, and the fact that that can all run in seconds or in minutes. So it's the kind of a testing program you can absolutely bake into a build cycle, and you can automate with a Jenkins orchestration, for example. So that's how a lot of our customers, actually automate into their CI/CD process. It's actually part of the build or the staging environment. They just make sure that the APIs go through an APIsec testing schedule. That literally takes a few minutes to run, and every time that test gets executed, we will reanalyze the API. So if you've got new code, new methods, new endpoints that have been released, we will auto detect those, build the missing tests to make sure that we're continuing to give you 100% coverage, and we will validate any of the existing vulnerabilities to see if any of them have been closed or if they remain open. So it's about as automated as you could expect or want it to be.
Perfect. The most dangerous attacks are insiders, so internal use is highly recommended. Is that correct?
Yeah, Bernardo, I'm dominating the answers here. Apologies, but we actually get questions or comments sometimes from people that say, "Oh, my APIs are internal only, so I don't have to worry about this." And that's just simply not true. We're all very familiar with the insider threat. Whether it's malicious or unintentional, but those APIs, whether they're internal or external, provide direct access to just wealth of information, data, sensitive information, and the like. And so for organizations, whether their APIs are externally available or just internal, you have to take the necessary security precautions, especially when we're dealing with privacy information and the like. There is for compliance purposes and the like, these APIs are absolutely the target of malicious hackers or insiders, and you need to make sure that those APIs are not exposing information that isn't necessary or isn't available to unauthorized users.
Perfect. This question is for you, Bernardo. What is your vision regarding LATAM's adoption of digital transformation best practices?
Digital transformation best practices have been lagging in LATAM. A lot of the companies took their time, they figured out, let's see what they do in other countries, how things work. But I think 2020 was a wake-up call. 2020 was a year where you needed to adapt or die. And so many companies in Latin America are looking at how to do the evolution of their business. How do you adopt the right, correct practices for digital transformation? Because the reality is that from now on, it's not just during the pandemic. From now on, people are getting used to things. People are getting used to work from home. People are getting used to use more their mobile app to do transactions in the banks, to do shopping. So to be able to have that and to grow and to make sure that your business is there doing the right things, it's very important. And I think most of our customers are now in Latin America, and not all of them are realizing the importance of having a very good business in the transformation area of electronics and adapting to a mobile world.
Perfect, thank you. We have another question. Can Selenium scripts be used? And I will throw this out to you, Dan, or
yeah. So I'll have to sort of confide that my technical depth is only so deep. I'm familiar with Selenium scripts. We have really a fundamentally different approach to security. We know a lot of people use Selenium, Burp, Zap, and all of those really require the user to actually create and author the tests and to record the sequence and so forth. we have just a different approach, which is that we actually, auto-analyze the API and then auto-create all those tests. We'd love to spend more time with you one-on-one and understanding like what the specific types of logic that you want to run. And if it's not something that's auto-created in our platform, it'd be interesting to talk to you about what those look like and what your use cases are. But the main difference between what APIsec does and sort of classic testing tools and test platforms is that those are great for replaying tests that you have created, but it still relies on you to author all of those tests. And with APIsec, what we're doing is we're auto creating those, and we're giving you really robust coverage and ensuring that those tests can run at the speed of your DevOps, and that you can make sure that that code gets evaluated with every push to production. Beyond that, I'll have to admit I'm not overly familiar with Selenium. I know it's a way to record and to replay tests, but I just wanted to sort of convey that we have a different approach to how we run.
Perfect. Is there an update mechanism for this as new vulnerabilities may come up?
Yeah, so I'm going to put my old Qualys hat on and it kind of, again, sort of convey how we're different. So we're not looking at CVEs and reported vulnerabilities. The reality is the types of vulnerabilities that we're looking for are not common, right? They are unique. They are your own personal 0 days, if you will. These are vulnerabilities that exist in your code, not because you're running on a certain version of a platform or a piece of code or a library or something like that. These logic flaws are unique to your organization and won't get reported or revealed in a CVE update or something like that. So what we do is we constantly are growing and expanding the intelligence of our coverage of all those attack categories. When I joined the company, those categories were something like 70 or 80. Now it's over 100. 30 of those attack categories cover directly the OWASP top 10. 70 go way beyond the top 10. And so as an APIsec user, you get that sort of continual growing repository of knowledge. We also have a marketplace where you and the community can also create your own attack categories and logic and so forth, and begin to start sharing those with each other. But just to sort of reiterate, these are not kind of common vulnerabilities that we're looking for. These are unique vulnerabilities that are unique to you. And for that reason are especially dangerous, because unless you find them, in Corey's words, some attacker will. And you really need to make sure you're able to discover these.
Perfect. Thank you. Bernardo, did you want to add anything to that?
No, I think very complete answer. If you, I love that Corey quote. If you don't find those things by yourself, somebody's already looking at how to find them.
That's right.
So keeping with that in mind, the next question is, and I think this person was just trying to ask on what they're seeing. So they're saying browser displays the network API request and response, and browser storage. How vulnerable is it?
Can you repeat that? I'm not sure I fully understood.
I think what they're trying to do is explain what they are seeing. So they're saying browser displays the network API requests and response, and browser storage. How vulnerable it is.
So if I understood the question correctly, and apologies if I'm not, yes, it's very easy to kind of reverse engineer an API. You can turn on developer tools, you can see the calls that are going back to the API, and attempt to leverage those APIs to write your own scripts to call them directly. And frankly, that's what happened with Venmo. Right? This was not a published API. This was someone who discovered that homepage was making a call to a back end. They could write a script to try to make the same sort of call and then see if it worked. It did. And then they just simply iterated literally 100,000 times a day running that query. So it's interesting. I was talking to another vendor where they have a published API, and they tell their customers, oh, by the way, if you want to use our unpublished APIs, just go ahead and look at look at our portal, and you could probably decipher it yourself, kind of like the rogue APIs or the unpublished. So that just kind of reveals like these APIs are almost a roadmap for hackers. Like in order to leverage the functionality that they have, in many cases we actually publish the documentation, or if not, you can sit there and watch the calls and responses from the server and how the API is structured. It just goes to show, how critical it is to make sure that there aren't any loopholes in those APIs, because we actually kind of make it fairly easy for hackers to see these APIs and how they're constructed and what they can do, and to attempt to repurpose them in ways that they were not intended. So I think that just reinforces the point of how important it is to actually find these vulnerabilities, especially before they make it all the way into production.
Yes, security by obscurity has never worked.
That's right, and here there's very little obscurity.
Perfect. We have another question. Can this test be combined with fuzz testing?
And actually, in some ways, we actually incorporate fuzz testing into what we do. And what's cool about what APIsec does is we actually will iterate all of those different unique tests across all different types of users, different methods, different roles, with different variables and the like. So it's actually part of what we do. Is to make sure that we're exercising those calls and those methods against every permutation that we can come up with, right? And that kind of sort of hits the point of how hard it would be to scale to achieve that level of coverage without an automated tool. We work with a lot of pen testers who are now using APIsec to support their efforts. So they spend more of their time analyzing the results, or perhaps coming up with unique, very specialized types of tests, and that they can rely on APIsec to do the sort of air cover of the entire API, and they can analyze the results and make sure you're focusing in on those most important and high severity vulnerabilities.
So you created a new business segment.
Yeah, exactly. That's right.
Perfect. Another question that we had is, what is the role of AI in the process that APIsec utilizes to test APIs?
Yeah, I think you sort of see it there, right? That sort of magic step where we analyze the API and really dissect it and understand it, break it into its components, and then mesh that with the library or the knowledge base of those 100+ attack categories. Those attack categories are not kind of pre-canned lists of tests. They are definitions of categories or attack types. And so there's a lot of clever engineering and intelligence to mesh your API's logic and structure into those attack categories, and then to fabricate all those tests that can be executed and run at speed with automation against your API. That's the actual execution of a test is not rocket science. The creation, the logic of fabricating all those tests to ensure that it makes sense for your API, that it exercises every aspect of your API, it runs through every permutation. That's where that automation, that intelligence of the platform comes in.
Perfect, thank you. The next question that we have, and actually Bernardo, this is going back to, I know you were sharing information about Latin America. In terms of Latin America, should the companies in Latin America be thinking differently about API security?
I think that the cyber attacks are global. They are happening from everywhere, and it doesn't matter. The internet made a very flat universe where everybody has some address there that you can find, and it doesn't matter. You can reach them and you can attack them. So no, Definitely not. We need to consider that all the sophistication that things are happening on cyber attacks here to the Defense Department here in the US, to banks, will be applied to our institutions in Latin America. So,
and Bernardo, you mentioned that the Latin America has been lagging on digital transformation. It may be that they're lagging in some ways on the level of security on those APIs as well. It could actually make them very ripe targets for these attacks.
yes, now there's more experience of people from the beginning and thinking about security, but some people feel very safe because they are doing some pen tests, and after some years of experience, we realize that pen tests are good to say to the government or to the institutions, yes, we meet the what you request me to do, but it really does not provide all the security that you want.
Yeah.
Perfect. What is the most common API security incursion?
Well, I think you just have to go to the top of the list. That OWASP API top 10 is pretty much in rank order, and that number one is broken object level authorization. That's the postal service example. That's the user A accessing user B type of vulnerability. And you could see, how easy it is for those types of loopholes to creep into an API, and how damaging it is if they do. And how much of a, that's sort of the holy grail, I suppose, of an attacker, is to discover that kind of a logic flaw in your API. So I think that's the OAuth number one for good reason. And it's especially difficult to detect with a runtime, firewall or gateway, because it requires some user and data context. It needs, those types of tools would have to know that I'm accessing my data, not Bernardo's. And sadly, runtime solutions aren't that level of aware. Or at code times with static analysis, similarly, it's very difficult to detect those kinds of vulnerabilities. So it's really in the test phase that you're able to uncover these most difficult and dangerous types of vulnerabilities, and why pen testing is such a critical function, and why we've tried to build some automation capabilities to help you find those.
Perfect. Bernardo, did you want to add anything to that?
No, I think it was very, very complete, very, very well structured. Dan knows his business.
Yeah. Perfect. There were two things I wanted to mention because I noticed it come up a few times as a request. We will be sharing the recording of this webinar today. It will be sent out both by email as a link that you can go and access and watch. It will also be shared on social media for Near BPO and also for APIsec. So we will be sharing that, and I know that some of you requested the hard copy, so please do send that in as a request. We have seen those questions. We will reach out to you directly as well. There will be a survey sent out following this webinar as well, and if you're interested in the pen test, please note that the link has been shared in the chat with you as well, and it will also be shared in the email with the recording that you receive. And when you get the survey, please do take a minute to answer the survey. And if you do say yes to the pen test, Near BPO will be reaching out to you for that as well. I'd like to now turn it over to Bernardo and Dan to give some closing remarks. Bernardo, if you wanted to just take it first.
Okay, of course. Thank you very much. I'm very impressed. We are an hour and there are still 50-some people here. So thank you very much to all of you for listening to this. I think it was very interesting. For me, when I first started interacting with the team from APIsec, was eye-opener, even after all those 9 years of experience doing things related to APIs. So I'm happy to know that you are finding it interesting, and hopefully we will be able to work together with you and continue to provide the type of service that you expect from us. Thank you.
And thank you, Bernardo. It's really been a pleasure to collaborate with you and become a Near BPO partner. Thank you all for sticking around and listening, and for all those really great questions. I'll just remind folks of the offer here. Just go to apisec.ai/free-test, and we'd be happy to work with you, show you real live results on your own API. It's cost-free. There's no charge for this, and we'd certainly love the opportunity to show you what we can find in your own APIs. So really appreciate everyone joining us today.
Thank you, everybody, and have a great day.
Thank you.